Hello everyone, welcome to this stream. Today we will be talking about mostly just updates to the hardware for the iCEBreaker bitsy and the Glasgow. So a lot of things happened since last week, and I would like to just mainly give you an update on them. And today we also have a guest on the stream in voice, Jordi Parky Rodriguez. Welcome
Hello.
to the stream.
Thank you very much.
Nice to have you here. So, as I told you in the previous streams, Jordi was working on. So, Jordi offered very generously not only support on Patreon but also in help in designing some hardware. So he was working on the iCEBreaker bitsy, which is this board. Let me see. So that's this board. So that's the previous version. And so, Jordi, what did we do? What did you work on?
Yes. What did we not work on?
Maybe I pull it up on the desktop here, the updated version.
And I'll pull up the change log. So I guess the biggest difference is the change in form factor. So we decided to change from the 1bitsy form factor to the teensy form factor. So the only difference really is basically shortening the width of the board by one row of pins. So it's 14 pins instead of 15 pins wide.
Or long, you mean?
Long, yeah. In the side-to-side direction as it is on the screen right now. And so what the benefit that brings is if we're teensy compatible, we can use all of the teensy shields or hats or whatever they call them, as well as all of the feather hats, because Adafruit makes a teensy to feather adapter.
Yeah.
Which is beautiful. Basically means we can use the existing ecosystem for everything.
Yeah.
So.
And I think this pinout is also pretty good for the teensy form factor, because the ICE40 UP5K has a pretty limited pin count anyway. So the additional pins we would get on a feather, because it can be extended as much as you want, is like not 100% necessary in a way. So we can basically plug into two ecosystems at the same time.
Yes, and actually I believe the feather and the teensy have the same number of pins. The only difference is on the feather there's the addition of the battery connector and different mechanical footprint. But by targeting the smaller of the two, we can easily adapt to the larger of the two, and so it's like the best of both worlds. So we've made a couple of other changes. We switched. Peter, if you want to talk about this, the USB-C connector.
Yeah, we did go to USB-C. More people will be happy. It's like I do warm up to the USB-C connector, especially with this pin out. So we will be testing it on this board too, and I think that will be exciting to have because more and more people are using USB-C, and it's like, yeah, if we can, then let's just swap to it and see how it goes. So I assume a lot of people will be excited about this.
Yeah, so that's going to be super exciting. I personally am on the USB-C train, so
I won't stop you people. It's fine.
There were a bunch of DFM, DFA changes, which is design for manufacturing, design for assembly. So just switching out various packages to consolidate part count with Glasgow and things like that.
These are the power supply chips. Yeah, these are the linear voltage regulators.
The RGB LED was this really small part, and so now it's this significantly larger, easier to solder part. Things like that.
2 by 2 millimeter instead of 1 by 1 millimeter part, which is nice. I assembled it on the prototypes, and I was like, ooh, that will be fun to build. It's fine for a prototype, and it's very cute. But I decided it would be better to go for a bigger part, just DFM, essentially, as you say, yeah.
Yeah, and we ended up having exactly enough room for that, so that ended up being okay. We also did things like, oh God, what did it say here? We moved the oscillator back to closer to the clock pin, so we don't have this crazy long clock trace going between the clock and
George Locamides will be very happy.
And now we have the PSRAM chip on the top instead of on the bottom, and I believe it will be installed from the
by default.
Yeah, by default. Okay.
Yeah,
which is
so
awesome.
so this is the reason it's like the part we moved it on the top, because it is very useful in a lot of situations. The other change, by moving it to the top side, we also added a jumper so that we can disconnect the chip select line for the PSRAM, because I ran into this issue that some designs were using the green LED for just indication of stuff, and then also trying to talk over SPI to like the flash or to the PSRAM, and then it's like, oh, oops, we can't do that, or no, to the flash. That's what it was. So using the green LED to indicate stuff, talking to the flash to read code from, and then basically the PSRAM was just corrupting data. So yeah, that's we needed the jumper in there. So it is on the back here. There is a jumper.
Yeah, Peter, maybe if you could open up the folder that the 1.0 E or A folder, and there's an image directory in there, and you can pull up some of the pre-rendered images that I have that show this a little bit better.
There's the 3D rendering too, but yeah, I can pull it up in a second. So.
Yeah, okay, this is perfect. Yeah, so you can see the top and bottom, and on the bottom, we have I think a better layout for the actual pin ordering, and so all of the diff pairs are next to each other, and you can see the little plus minus indicators there. Which is
you did an amazing job, because this is a nightmare to route.
Thank you. Yeah, it turns out that the most of the diff pairs are not actually next to each other on the package, which means that you have to do a bunch of crisscrossing, and was not very fun. Well, it was fun. It just took a while.
Yeah, you did it. Respect.
Thank you. So we have that. I actually did have one question for people and for the chat, which is that Sivan mentioned wanting to change the indicators on the bottom to be the number of the pad of the QFN, because that's what's used in the PCF file. But my thinking was that if we have an actual default PCF file for the iCEBreaker bitsy, just like we do for the iCEBreaker, then it might actually be better to have the names of the pins on the silk screen rather than the actual QFN. I don't know if anyone had any thoughts about that, but
yeah,
if not, then we'll just leave
I have mixed feelings about this. It's like, so it does make a lot of sense to have the FPGA chip pin numbers in a way, but also you have quite often just a PCF file or pin constraint file that already has the numbering of the pins of the board instead. So I wish there was in the tools in the FPGA development tools, like that there would be like an abstraction layer somewhere where you can have, so you have that already in NMygen and Mygen, where you load a board file with certain already pin assignment to the internal FPGA pins, and then you work from the pins on the board, which are more logical from the like geographical positioning, and so basically, yeah, they would be counted from 1, 2, 3, 4, 5, 6, and so on, and then it is like, if you look at the top of the board, you don't have to, especially when this is plugged into something, then you can just count the pin, and then you know which one is which.
Plus, Teensy already has a standard for this, which is 0 through 23, and so it would be really nice to have that. But like you say, there isn't that abstraction layer.
Yeah, and there's, as far as I know, Yosys doesn't have like a way of abstracting the PCF file. So basically, have it like a PCF translation file or something. So that would be very useful if we had that. I know we can do that in NMygen and Mygen. So, but yeah.
I guess a couple other things.
That's why I have mixed feelings about this.
Yeah, a couple of things I'll point out is that the programming header here on the left is not going to be installed by default. That's just an optional surface mount 2x5 header that has the CDON, CReset, and then the quad SPI and power. And so that's for programming the flash separate from, like, before actually using the USB softcore. And then for the USB, we have, instead of the FTDI chip on the iCEBreaker, it's an actual implementation inside the FPGA. And so we're using
a bootloader.
Exactly. And we're using an actual diff pair for the USB traces now. And so that means that all of our GPIO pins on the exposed on the edges are actual GPIO pins, and none of them are constrained to being output only. We also have castellations. So if anyone wants to drop this down onto a motherboard, they could do that. And yeah.
Yeah, you should probably stick some Kapton tape on the bottom here too. Yeah, but yeah, this was your idea because you saw that that other
what is Arduino Nano 33 BLE or whatever, their new line of Nano boards are all castellated.
I think that's a great idea because then you can essentially build. So what I see this board being very powerful with is in designs where you don't want to deal with all this QFN stuff. I think it should open up it to people that are more comfortable in the through-hole world still, which I can understand. That does make things easier. So yeah, I think the castellated holes are also great because you can then SMD mount this complex board, quote unquote.
Well, and especially
it is very tight though. Yeah.
Yes. There is basically no free space on this board. We moved the vias. I moved the vias to the outside of the QFN instead of shrinking the ground pad of the QFN.
Oh yeah, and that was.
Yeah, that was a challenge.
That is a great improvement because several people were pointing it out, and that is a very fair thing to say. Is the problem with having the ground pad exposed and only having the solder stop being the insulator between traces underneath and the vias, it could cause problems. And the fact, we should give Greg DeVille a little bit of a shout out here because he basically proven that it should be possible to do. And originally I wanted to take it as a challenge, and then you stepped up and did a much better job than I would have. So thank you so much.
It was a fun challenge. Thank you for giving it to me. I was bored at home, so this is perfect. If you press S, actually, you can get rid of the 3D models, and then you can see what that actually looks like.
Which button?
S.
Oh, I didn't know that shortcut. Okay.
Yeah. And there's T for through hole, S for SMD, V for virtual. But yeah, you can see that we have the full ground pad area in there, which is good. And so I saw someone in the chat mentioning the USB shield. That was just an unrendered pour, and it is connected to the board ground through that resistor down in the bottom left.
So yeah, I switched off the fill. So you see there's a ground pour in here. So if we go to the board itself and I switch on the ground fills, and then let's go to the top. So they are there.
Yep.
Yeah. Cool.
So I don't think there's anything else to talk about with this. I think it's a fun thing to work on, and I'm glad it's finally polished up.
Yeah, so that's awesome. I think we are pretty much ready to order a prototype of this. One more thing that I want to mention in that context, because I was saying about the through-hole stuff, the teensy form factor is actually pretty cool in the sense of this is a pretty common DIP package format. So an actual chip from the olden days of through-hole parts. So there is even a company or a Tindy shop that is selling, this kind of stuff. So these are flip pins, and I ordered a bunch of them here. And so it looks like a pin header, but actually the plastic part you put this on and use the plastic part to align the pins. and then you remove the plastic part to make this an actual chip that can go in a socket. I don't have the sockets yet. They are in my cart on DigiKey, but I didn't press the go button yet. And I am really excited to essentially build like an old-time motherboard with the iCEBreaker bitsys. So we could build an like retro-inspired computer motherboard with several of those, and one would be like the CPU, one would be the video chip, one would be the audio chip, and whatnot. So it's like we could have those chips discretely on the board and connected with some kind of a bus. We are limited with the pin count, so it would probably be like a time multiplex 8-bit bus or something.
We could use Claire Wolf's PonyLink, which is the one-wire bus.
Oh yeah. Claire always has something really cool to offer. I was still thinking about using a more parallel bus to have more pins, but we are limited to basically 24 pins GPIO. Is that correct? I think that's what I counted.
24 pins. Yes.
So essentially we have 8 bits for the data bus, and then the remaining 16 would be for, I think graphics is the limiting factor if we want a full 24-bit video. So that's the problem, I guess.
Yeah.
Oh, what? The PonyLink takes half of the chip itself? I don't know what Sylvain is talking about.
Yes, the PonyLink. It's a huge number of butts.
Oh God. Okay. Well, that's I guess that's not great then. Yeah. Anyways, that was just one of the
1,700 LUTs.
Oh God. Yeah. So maybe not that, but I find it interesting as an idea to because maybe some people are aware of the RC 204, 2004 or something, 14. It's this like retro computer that this guy built, which I find really cool. Let's see.
RC 2014 Homebrew Z80 computer.
2014, right?
Yeah.
Yeah, so this is the Z80 computer. This is pretty cool. It has like a motherboard with like single inline cards that you plug in, and then you have those chips. And it's like, why can't one of those chips be the iCEBreaker bitsy, for example? So that's the thinking I have. It's like I like this retro inspired stuff a lot, and we have several people in the community building retro inspired stuff. So it might be interesting avenue to explore. Yeah, so essentially this is pretty much ready for prototype run. So I will probably order the PCBs this week. Is that right, Jordi? Unless we get some additional input.
Yeah, the only thing that I can think of that might change is the pin numbering. I'm partial to numbering them to the teensy form factor, but I totally understand why the pin number is better.
I see both having merit, like both make sense. That's the problem. It would be great if we could put both on there, but I doubt it is possible. Also, it would be readable. They would be so tiny that. So that's very cool.
Yeah.
And I will order the parts. So I don't think next week, probably like in 2 weeks-ish, we can do, depending on how the timeline works out with me getting the parts and the PCBs, we can do assembly either on stream, or I will assemble it and show it off on stream. So also it's important to give credit where credit is due. Sylvain did an amazing job on the bootloader for this, which is like a 2-stage bootloader, where you have a very small bit stream that is just checking if it should go into bootloader mode and starts the actual, if there is an existing one, it starts that as an application, or it jumps into the USB one that then enumerates, which is a very clean solution for how to build build a bootloader for such a system. So this is what we will be using on here. I already tested it. Also, this will be able to run at least not CircuitPython, hopefully too, but MicroPython for sure. Yeah, so I think that is the story. Anything else to add, Jordi?
No, I think that's it. Thanks.
Okay, cool. So let's move on to the second project. And I'm not sure if the RC... Yeah, I should link that in the chat so that people know.
I got it.
You can still buy them. People are building crazy plugin cards for it. Oh, you already did. Okay, thanks. You're faster than me. Yeah, so let me check the chat and maybe welcome a few new people that joined. So let's see. Did I miss anything in the chat? Teensy Feather. Yeah, there's the Sedacious. There we go. So yeah, this is just for reference. This is basically the Teensy and the Feather adapter board. The cool thing, the Feather is exactly 2 pins wider than the Teensy, so it really nicely plugs in there. I think that's pretty cool.
Oh, by the way, I also made sure that all of the I forgot to mention this to you, but all of the on the Feather form factor and on the Teensy form factor, there are default locations for SPI, UART, and I2C, and so I made sure to put those peripherals on diff pairs so that you don't have clocks jumping different pairs to get onto the peripheral and not. So when it gets routed from the Teensy to the Feather form factor, it should just work whenever we use the hard I2C IP and the hard SPI IP.
Oh, cool. Okay, that's awesome. That's really good, great improvement. Yeah, this will be now interesting how compatible the hardware designs will be between the full-size iCEBreaker versus the Teensy iCEBreaker. So, or bitsy, sorry. So this will be an interesting thing for the examples in the repository, but this is down the road. It's like, it's solvable, it's software. It's not a problem.
Yeah.
So yeah, Sylvain is pointing out that this is actually breaking Adafruit's Feather standard. Yeah, I think the position of the battery connector is fixed on the Feather, isn't it?
It is.
Maybe
but they didn't have any space to put it underneath the other part of the. You can kind of click and see that they have the shorter header there and they have space for it. It just doesn't fit underneath the Teensy.
Oh, yeah. Oh, this space here in the left upper corner.
Yeah, exactly.
Yeah, you can't put it there. Interesting. Well,
So,
it is what it is, I guess.
With all of the feather wings and stuff. It's just that the LiPo connector is at the end.
Mm-hmm. You need a Teensy to PMod. Yeah. It's a good point. Yeah. Everything PMod. We also need an iCEBreaker bitsy PMod that plugs into the full-size iCEBreaker.
Yes.
Yeah. It's like, I heard you liked FPGA, so I put an FPGA in your FPGA. All right, that's the meme, I guess. All right, so let's move on to the next thing. I think I addressed everything. Let's say hello to the few people that joined. There was a bunch, actually. So first of all, thank you so much, OX496, for the 49 bits. Thank you so much. I really appreciate this. This happened, I think, before the stream even, or in the community update section. Then Crazy Tech, thank you for the follow. Nathaniel Bongole, thank you for the follow. Welcome to the stream. Pirates Engineer, thank you for following and welcome to the stream. And Cartman ZW, thank you for following and welcome to the stream. So yeah, thank you so much. Yeah, and let's move on to the next thing. The next thing is the Glasgow. So we were working on some hardware updates on the Glasgow in the last few weeks, and I took the design and pushed it to a branch on the main Glasgow repository. And Electronic EO, he did a bunch, continued making some improvements and changes to the board. So I would like to show you what he did, because if Electronic EO, you are there in the chat, you're welcome to correct me if I'm wrong on anything on this. So please let me know. So let's open it up. File, open recent. I think that's it. Yeah, we don't need to save changes at the moment. I didn't do anything productive on there. So this might not be the newest version. Maybe I should pull before I continue. So yeah, let's see. Glasgow work, git pull. Let's see. Oh no. I'm not typing my passphrase on stream. Sorry. So yeah, it will be what it is. So he might have done some more updates. So Electronic EO, thank you so much. He's the great person that did also the board for the Pogo pin tester for Glasgow that we will be using. Oh, so I probably have the most current version. So this is the Glasgow. So he also made this, which is the Pogo pin tester harness, which we will be using. And thank you so much for that. And on Glasgow, I think the main change that you are working on is to change the ADC. The ADC that we used on there was a fine part, but I think this one has also capabilities to limit the current and monitor the current. So it is more capable part. Let me pull up maybe the datasheet. That probably is a wise thing to do there. There we go. No, I did div master, origin master. No, I have to pull it from the Git repository, and I'd use SSH, and I didn't type in my passphrase before the stream because I had to reboot the computer. Silly technical reasons. Okay, open documentation. So this is the data sheet for this. So this is not just just an ADC. It's also a bidirectional current and power monitor. So this part gives us more capabilities down the road and will expand what we can do with the Glasgow. I think the main motivator for EO was the ability to use it in other Pogo pin test jigs for his project. So he can monitor. We can monitor the current that the target is using, which is very, very nice additional improvement to the board. And so before we can order this board, we will have to finish routing this. And he managed to actually squeeze it into the same footprint that the previous ADC was in. So that's very nice. Yeah, so ABDCW, thank you for the follow, welcome to the stream. And Flying Walk 02, thank you for the follow, welcome to the stream. Yeah, so now that we did the updates, I don't think we have what is this the time? Oh, we have actually an hour still, wow. I was expecting that the talking will take up for way longer than this. So we probably should, we might be able to actually help out, and let's see, let me think. I hope that I really have the newest version of the Glasgow, because then we could try to lay it out and help out Electronic EO there. So let's see. So the vSense, oh, that's interesting. So how is this connected? I'm now curious. Let's investigate how this is interfaced. So we have vBus. So this is the vSense. So vSense is vBus. So I guess this is what the part can monitor the voltage of. And the vBus is limited to minus 0.3 volts to 40 volts. And then it is using the diff pair. That is for the current measurement, yes. Oh, so this is the current monitoring. So this is a shunt for current monitoring. That's if I see it right. Good point. I might do that. If I decide that we should do layout, then I might do that. That's a good point. Thanks, Sylvain. And the honeycomb system. Thank you for the follow. Welcome to the stream. So yeah, essentially this part has essentially two inputs. It has the voltage measurement input, and it has a differential current measurement shunt that it can use, and this is connected to each of the settable voltage regulators. So if you see, oh, this is, I want to fix this. It's like the dangling traces trigger my OCDs a little bit. So yeah, we have this. So how is this front end working, which we could talk about a little bit. We have, this is the correct use of I2C, just so you know. So this is the I2C interface on the Glasgow is only kept on the board and locally, and it is used for known parts on each where they are and where they are being used, which is the right application. Because don't get me wrong, there are good uses of I2C, especially when you have so many parts that you have to connect to something. We have the DAC, so digital to analog converter, and you can set this. And with that setting, you are configuring what the voltage output should be of this settable voltage regulator. So how does this work? This works by adjusting. So usually when you have a settable voltage regulator, it doesn't even mention that in the datasheets very often. You have this feedback loop. So it is monitoring what the voltage output is by using usually a resistor or a voltage divider. So it uses that to the feedback, and the feedback is meant to be a static value. And you can essentially bias this output with an output from a DAC with an analog voltage here, and by biasing it, you can pull down or up the output voltage that it should have on the VIO. So essentially, you are tweaking this feedback loop by inputting your analog signal into this. It's a very neat solution. I was aware of this existing, and I never actually managed to put it in a design. This is something people were recommending we should do for the Blackmagic probe. So Blackmagic probe, as you know, has this voltage output that you can use to power your target. Hello, who are you? There's a wire here. This wire is here. Go away. Stray wire, I just found it. It's like a hair somewhere on the on the drawing. Anyways, so so I was talking about the Blackmagic probe. So the Blackmagic probe has the power supply that you can set to on or off. So it is currently using just the internal 3.3 volt voltage regulator of the Blackmagic probe to power the target side of the level shifters as well as powering the target. It is fairly limited on how much current you can draw from it, but it is very useful when you are doing development and debugging and whatnot. Several people were recommending we should do something like this, where we have a settable voltage for the target voltage on the Blackmagic probe. I think everything makes sense here. So there are situations where you just want to connect. So the target power stuff I found most useful in situations where you have an embedded programming class and you just want to use one USB cable. So you connect the USB cable to the Blackmagic probe and the Blackmagic probe over JTAG to the target board, and you power both of them from one USB interface. That was very useful. The second useful thing is being able to set the I/O voltages on the level shifters. Currently, if you have something else than 3.3 volts, you will have to connect the reference voltage from the target and basically set that. And in case of the Glasgow, the inputs for monitoring and the power or target power voltage and whatnot, they are separate, which is a very nice solution. So you can use this sense wire to monitor what the output voltage should be and match it to supplement it, which is an option in the software. And there are many, so you just monitor it and use the settable voltage supply to power the level shifters. So you match your I/O voltages just doing that. So it is a fairly powerful thing to do, and I think this would be very nice to have that in Blackmagic too, where you don't connect the target, so you only monitor the target reference voltage and then drive the level shifters using your own power supply instead of the target reference voltage, so that you don't put additional strain on that voltage regulator. I'm not sure there's many situations where that is actually an issue, but it might be it might be useful in some cases. So yeah, this solution here makes it incredibly flexible, and essentially changing this part from just an ADC, so analog to digital converter, to monitor the voltage on the vSense pin, to a part that also is monitoring the current of the power supply here, makes it extends its capabilities, and we can do even more. And what the goal of the whole project is to move the hardware problem into a software problem. And the more the hardware can do without adding significant amount of cost, I think is a very reasonable thing to do here. So thank you so much, Eel, for making that addition. And I think that's, also you can set an alert. So that's an important part of it. So when the current, I think is the current and voltage monitoring that this part can do. So if it exceeds certain thresholds, it can generate an alert, as far as I understand. So that's very useful. Yeah, that said, I think I will do what Sylvain suggested, and I will add the HTTPS remote repository. And we can do a little bit of layout on here and try to squeeze this in. Oh, yeah, so I essentially didn't do very much on this since last week, because I am working on documenting the conversion of a reflow oven from one of those Chinese reflow ovens. with all the changes I did myself with like an updated firmware with a thermocouple interface. I finally getting to it. So I spent the last 4 days essentially just doing the conversion and filming it. I'm still surprised how much more time things take when you have to make photos and film it. So this is, yeah, I think I can show you. There's nothing offensive on the floor here. So let's see. Let's use the desktop cam. So there it is. So that's the oven. Let's focus it. Focus button. Yeah, so this is the just Fui T962A oven. Doesn't look like much, but I already did the thermocouple interface exchange and like removed the masking tape that they are putting in there, which is completely stupid. So the problem with this oven is, the main offensive part is that they are using this masking tape inside, which is, when you heat it up, it starts stinking very strongly. It's like you really think you will get some horrible lung disease from it. And so the first thing you really have to do when you buy one of those is remove that masking tape and replace it with some thermal tape like Kapton tape or something. So that's what I did, and the thermocouple interface is an improvement to actually stabilize and make the measurement of the internal temperature actually accurate, because they are using just potentiometers and some op-amps to measure the thermocouple interface. So this isn't very inaccurate. It's like tracking well on the low end and then suddenly goes away, and also it doesn't have a cold junction compensation. This is a thing you need to do with thermocouples to have actual accurate measurement. They just assume a certain temperature of the ambient and then using that to anyways, it's bad. But you can solder this small board that has proper thermocouple interface chips with a one-wire interface, and then reflash the controller on this thing, so you don't need to throw away any of the hardware in there. You just flash a unified engineering firmware on there, and then it is actually tracking well, and it has a PC interface over serial that I never use. Anyways, so I tried to document this. I filmed everything, I photographed it. The last thing that is left is the fan for the electronics that I have to mount, and I have to drill out the holes and whatnot, but on the fan itself. I didn't have to drill anything on the oven itself, but yeah. At the end, it becomes a very usable. I use it for all my production currently still, and it works pretty well. Yeah, so this is a pretty known set of modifications. A lot of people did that. I find these modifications, if you don't have to film it, just take one afternoon. The thermocouple interface chips are not the cheapest. They do add, I don't know, like $30 of cost to the oven, but they are really worth it. Yeah, so yeah, anyways, I will have to finish filming this and do all the editing on the video, which I am already looking forward to, as you see. Yeah, it has to be done. This topic comes up on such a regular basis, and I find the Chinese oven with modifications works very well for me. There is the alternative approach of buying a pizza oven with modifications. I'm not sure how they compare price-wise. I heard they work very well if you do the right conversions. But from what I heard, if you want to do the conversion yourself on the pizza oven, it's quite large project to do. this conversion of this oven is seriously just one afternoon of changes. It's really not hard. Reflashing the controller is just, you need an FTDI USB to serial cable, and that's it. I find the pizza ovens, if you buy a modified one, that might work fine, but it's like if you want to do it yourself, it's much more work. Yeah, okay, yeah, people are doing that, I know. Yeah, I find this, it's like, for the oven you pay, I think, $250 to $300, depending on this seems to be the first one that is actual genuine Fui so far. So the two ovens I bought before were some knockoffs of that oven, which is very interesting. I had no idea they cost all the same, and it's really hard to figure out which one is the genuine one. So you buy them from eBay anyways, and it's like, yeah, which one is the actual real one? Because they will advertise anything they want, unfortunately. Yeah, I'm glad it works. I rather have this oven. The biggest issue that it has, even after all the modifications, the working area is not as big as the full bed, so you have to be aware of it. So you can work only like in the center area of this size, even though the drawer is much bigger. People were trying to address this with adding some additional fans and like distributor things. You can see it in the issues on the Unified Engineering repository. But it's like, it's still big enough for everything I was doing so far. And my panels, let's see, how big do they get? My panels do get this size, and it's like 4 Glasgows big, or a little bit bigger. So if your projects are not too big, it's totally fine. And I still feel a little bit more comfortable using hardware that is actually meant for the purpose instead of repurposing a pizza oven. But that's my take. Yeah, it does do BGAs. Oh, you couldn't solder it in your pizza oven. Interesting. So yeah, it works fine. I did several batches of the HyperRAM PMODs in there, even on yeah. So it worked fine. It's just because I started with the oven with no modifications and then did the modifications, I realized what the advantages are of those, and actually using one of the default curves on there is pretty much good enough for most of the stuff that I'm doing. I know I could tweak it and like use a software to calibrate the curves and whatnot, but yeah, this is the question. It's like, at the end, the question is what oven works, and it's like, all I can tell you is I know that this oven with those modifications works for me. It doesn't mean it will work for you, I guess, but maybe that's a good pointer. And for the pizza ovens, there's a lot of options. You can buy many different ovens, many different modification kits, and many already pre-modified ovens that exist. So yeah, it's hard to know which one is which. Yeah. Zipfel, you are lucky. Zipfeli, yes, that's nice. That's a nice nickname. All right, so let's see. Oh, wrong. I'm clicking on everything but not the right thing. So let's get the link. Where is it? Glasgow embedded, Glasgow. Let me copy the HTTPS link. Origin, like this, I guess. Yes, git fetch origin HTTPS. Will that work? Yes. It hello? Yeah, okay, so I am up to date. Cool. That's all I wanted to check. Ah, Sherbrain, welcome. Or Jared. Nice to see you. How was lunch? I assume you were out for lunch until now. Yeah, so that is updated. So if you see that my command line changed once again, this is power level 10K. I really have to say I like that command line mod for iCEBreaker. So yeah, if we are talking about random stuff today, pretty much. So yeah, first of all, so this is the config that I'm using for Z shell, because several times people were asking what I'm using here. So that's iCEBreaker, and then I'm using power level 10K. This theme for the command line, and it has a lot of configuration options that it automatically asks you. Oh, you are deep in Radioland. So are you still trying to track radio transmitters in Portland? That's still the topic. So yeah. Okay, cool. So let's see. How did you lay this out? Let's see. So we have. I should probably have the schematic. I wish I could have that. Okay, so this is just a decoupling capacitor. This is the double diode for VIO enable and alert. Huh, interesting. So this pin has like dual use. And then this is the capacitor for the diff pair. And then matching resistors, I guess. Yeah, one. And where's the other one? I can check it like this. Yeah, I know. Yeah, Zipfeli, I know. I have to definitely update the theme on KiCad. There's so I think this already works even in the stable version. Just the nightly makes it easier to do. To load different color themes on schematic and the board files, and it makes it much less harsh, less primary color. Yeah, it's good. When you will see it, I will show it on the soon to come streams. It's much nicer than stock. You made Nord theme. Ah, okay, cool. So let's see how that looks. Oh, this is the color set.
That's just the site for the main theme, but I made a KiCad version. And all the top layers are warm, all the bottom layers are cool. So by looking at a layer, you can tell whether it's on the front or the back.
Wow, that's nice. I have to install this. Do you know how this works for the stable versus nightly build versions? Because the
Well,
nightly, I think, have a way of importing and exporting stuff from the UI, and in the stable, you have to copy it in a folder or something.
yeah, I think so. I just literally made it for myself for stable. I use Nord for all of my other software, and so I was like, I need it for KiCad. So I don't have a
Ah,
link. It's in my dot files, but I'll try to find a link and post it in chat later.
you have to share stuff with people.
My dot files, but you have to search through my Arch Linux dot files to find it. So
Yeah, that's fine. That's fine. Yeah, no, that looks really good. So this is the advantage of the nightly builds. I think you can actually export config file for the colors and share it with people. It makes it easier. The current the nightly. Am I conflating things again? I think, yeah, what I meant to say is the nightly build has an option to import export this, and the stable version does not, so it makes it harder to share these kind of stuff. Oh, thanks for the link. Awesome. Sweet. Yeah, I will definitely do that. Yeah, let's keep studying how this looks here, how this works here. Where's I still want to see where the other resistor is. Symbol. Oh yeah, nightly builds also have highlights for symbols in the schematic, which this stable doesn't. I'm looking forward to that. So this seems like a highlight, but it's not. It's actually this highlighting what you selected in the board file. You can't just, yeah, if you select it here, it just goes gray, and I don't think you can like select it by just clicking on things. It's weird. Yeah, KiCad has some still usability things that it should work on. Always something to improve. Yeah, there was a lengthy conversation how to implement highlight in schematics. So now it is, as far as I know, like this haze around parts and around symbols. It doesn't look bad. All right, so this went over there. So there is a bunch of stuff that is pushed underneath the voltage regulator. So essentially, I probably should just move this stuff in here and just squeeze it in. Or I will leave it to Electronic U to finish because he already did the top part. I don't know. Am I being mean or not? All right, so let's see. So let's see that. Where did it go? It went here. I wish I could. There is an align thing, but it's like align two part. Like there are some controls that I know from graphics programs that would be nice to have easier access to in KiCad, or at least I should learn how to use them better, I guess. Oh, I am like on 0.1 millimeter. Why am I on such a fine grid? Yeah, that's better. How does this... Oh, so he has a gap there. So this is another thing that I'm looking forward to in version 6, is you don't have to... If you have stuff that is already laid out, like this area, you can essentially have a second copy of that with the layout. The link does not show the Discord link. What do you mean? So Framework 02. So this link that you see here is going to my website. What is on there is this frame. So I will show you. So this is how it should look. This thing is how you get to Discord. And if you have like a plugin that say Privacy Badger or some other tools that disable plugins into pages, then this might be not showing. I saw that, I think Privacy Badger just hides this, for example. So you would need to disable Privacy Badger for a minute for that page so that this plugin loads. And I'm using that plugin instead of posting an invite link is because the invite links do expire. And I also want to have a little bit more control over the invites, just in case. Blasphemy, yeah, yeah, that's a good point. It's like, how dare you disable my privacy? Yeah, fair enough. But yeah, Jordi just posted the invite link, so I should probably make it so that the invite links always lead to the welcome channel, because it is important, I think, that people see that there is a link to the code of conduct and whatnot stuff. So I need to tweak the settings in the Discord probably a little bit. Oh, FreeBSD Firefox issue? Oh, you're a FreeBSD user? Wow, those exist still. That's nice. I'm sorry that I'm being a little bit surprised. Is there an expected release time frame? Oh, geez, I have no idea. I wish there was like a better time frame for this, but I don't feel there is still a lot of work to be done. Can of worms? Yeah. No, I think. Jordi, do you mean like opening can of worms as in FreeBSD versus Linux or something?
No, I just meant the can of worms as in asking for time frames for releasing of software. Open source software.
Oh God, yeah, no. So yeah, as you see, I always try to not make too many promises timeline-wise, because I know they tend to slip, especially in open software. So Glasgow thing, for example. So because we made so many changes now, we need like a new revision run, and it's like the problem I have very often especially when the projects are designed like to a degree outside of me messing with them. It's like but it's pretty much with every project, even if I design it myself. If I start engaging with the project, it's like, we can fix this, we can fix that, and also doing it as a community and interacting with everyone. People have great ideas, and then you are like almost done, and then suddenly someone says, it's like, you know what, if you did this and this would make it better, and you're like, damn it, this is a great idea, I need to implement this, right? And yeah, it is dangerous regarding feature creep, but it makes for a better tool, right? Yeah,
exactly
we did that.
Sylvain has given so much good advice, but I was like, oh, I'm all done with the bitsy, and then Sylvain's like, oh yeah, could you rearrange all the pins? I'm like, yes, and now it's so much better, obviously because of that happening. But yes, it's the danger of open source.
Well, yeah, it's the danger of embracing open source. You suddenly have 50 additional brains with good ideas that, and more often than not, I feel these changes there are changes where you will dismiss them and say, it's like, well, this is too expensive and it's outside of the scope, we will not do that. Right. But then there are majority of them, it's like, well, if you add this jumper here that is free, then we can do this too. And then you're like, well, yeah, hell yeah, we have to do it then.
Yes, exactly.
In the worst case scenario, you say it's like, well, not in this revision. I really need to order this board. So that happened, but then I make the next revision and I add this usually. So yeah. And this is why I love I coined or tried to coin the term of like design by Twitter, and it's essentially posting your design on Twitter and then getting a lot of people and this is why it's like people saying it's like, oh, the Twitter is so caustic. It's like if you create the right community of people that actually give you good ideas for the hardware, it's not. It's like it's such a complicated topic that we talked in before the stream. But it's like this is the core of this. It's like we can have a very positive and helpful, inclusive, and also technically advantageous relationship on there, and I find that really awesome. Yeah, making better stuff, making better tools that work for more people, right?
Yeah. Alex just brought up the point of stealing ideas from open source. That's true, but hardware that's good hardware is going to get stolen by manufacturers in China anyway, no matter if it's open source or not.
Yeah. Well, also, where do you draw the line of stealing per se? If it is open source hardware, in general, you are licensing it so someone can build it. Hardware doesn't. This licensing that you put on the hardware designs usually only affects what you would like people to do with the hardware, not what you can actually legally enforce. Because actual hardware things are governed by patents, not copyright-based licensing. So it's a very complicated topic in itself. So I can only express my preference how I would like people to use this stuff. Yeah, so what you can enforce, for example, is if you have your company logo on a PCB and say it's like you are not allowed to use my logo because I have a trademark on this. And then you can take down things on AliExpress too, or like really pretty much enforce it. But I took rather the approach of not having the logos and the brand name on the design files. So if someone makes them without actually doing anything to it, at least it is clear that it is not made by 1bit². So that's my approach. Because I rather build stuff and spend time creating new things than prosecuting stuff. So that's my feel. And yeah, I do appreciate if people buy the hardware from us, or 1bit² or Crowd Supply or Mouser, instead of buying them from someone in China who is trying to make a buck, but they are not really part of the community or contributing anything. So, but I said that many times here. Well, the one that was using all the assets copied from our campaign, I made them take it down. But right after that, they spilled like 30 stores with different random number names, with just a shitty photo of the board. And so essentially, it turns out there's like one supplier in China that is making this kind of boards and then selling it to a bajillion stores. That's how they do business there. And that means it is popular in a sense, which is nice. But on the other hand, I appreciate if people get it from us instead of them, because that is keep food on the table here, so I can continue making more hardware. So that's as simple as that. So I can spend now what? I did spend several weeks now on the improving the Glasgow design, and I keep working on this kind of stuff. So this is the Patreons are wonderful. That helps a lot with the streaming stuff. Yeah, my main business is selling hardware, and that's what pays for being able to continue making more hardware, making new things. So yeah. Oh, assembling yourself. That's a very good point. Thank you, Symphony, for mentioning this. I think that's great. This is why I make it. So there are two reasons why I make open source hardware. One is people can learn from it and debug their own tools. Second is people also learning and building their own. You're very much welcome to buy parts and build for yourself the hardware, if you see it as a challenge, a learning experience, as a fun thing to do. I don't have a problem with that at all. That's great. What I don't like is essentially people trying to make $1 on selling half-priced, barely with any margin versions of the hardware, because this is how they can just make money by taking all the different open source hardware, just putting it in a one huge garbage bucket and produce 1 million of them to make a cent on each one. I don't know what advantage it brings, really, except maybe giving a little bit access to the few people that really can't afford it, I guess, and still want to have it. So it's a hard problem here to talk about, but yeah, if you want it for cheaper, build it yourself. That's how I would recommend. Then you will learn something from this at least. So that's the advantage. But yeah, I hope that answers your question. So yeah, as I said, I don't have a problem people building their own. I think that's great. People are learning something from it. Glasgow, for example, there's a lot of people that built their own by now, and even modifications. There are like several modified versions, so it's wonderful. People learned a lot from it, and we also learned from that. This is the essence what the argument for open source hardware was in the first place, where people are building several versions. At the end, if you make a product like the iCEBreaker or the Blackmagic Probe or whatever, it ends up being that most people don't have really the time to actually assemble it themselves. They want the tool, and they want a good tool. And these tools, White Quark mentioned that today on Twitter very well. It's like open source software should be better than the vendor software. That's a very good sentiment. The same should apply to hardware. So if we are building it as a community, we should, because we can build it with more brains and use cases together, we can make better hardware, but we can also make better software. That's the utopian vision of doing things open source. But still, you have to support the people that have to make money so that they can continue making the open source hardware and software. So this is the complicated relationship between this altruistic, shareable, socialistic approach of hardware and software versus the capitalism we live in. And there has to be a good balance between one and the other. On your workboard, yeah. So yeah, we got completely on a tangent today, which is fine. I think having a stream that goes on weird tangents from time to time is totally fine. Yeah, so what I'm working on is the second half. So essentially the Glasgow has two halves. There are two banks of 8 pins. Each bank has 8 GPIO that have level shifters. And then you have these two chips which can set a pull-up, pull-down, or nothing. So you can have on each line. And then you have a DAC, so digital to analog converter, which sets a voltage for a voltage regulator. And then we have an ADC. We used to just have an ADC. Now we are changing it to a part that can also monitor the output current. So that's what we are working on. So do you work on the plans of the board in open source before producing it? Yes, I started doing that eventually. So the advantage of having a community look over the designs and giving their input and ideas is incredibly valuable. I saw that most actively for the first time with the iCEBreaker. The iCEBreaker would not be even remotely as flexible and hackable and expandable as it is if not a massive amount of input and discussions in the community. So the community lives on Twitter as well. So we have the hardware hacking FPGA related Twitter community is pretty strong and very, very vibrant. So I recommend just follow me on Twitter, and then you will see what the other people I'm retweeting. It's like this is what I do. And then we have the Discord for 1bit², which a part of that community lives on. This is being posted here from time to time, a link to that Discord. And thirdly, there's even a broader community of the open source FPGA people and hardware hacking community, which is SuperCon conference that is organized by Hackaday, or Teardown, or from a Crowd Supply, or all these groups are interconnected with with the people, and it is a very, very nice community with very technically savvy as well as very inclusive and friendly to each other, and that's what we should continue making and improving. Well, you mean like tech horror? I think White Quark likes to post tech horror stuff, where it's like, here, look at this weird pinout of this chip, which is like, who came up with this crazy thing? I think that's the level of horror that I've seen on there. Yeah, so as long as it is just tech horror, it's fine. It's like any other horror, please don't. that's just bad. If there will be a recording of the stream at the end, if you want to hear a little bit more of the in-depth discussion of the community stuff, I did that before the stream, and there is a recording on Twitch. This will not go on Twitter, on YouTube as a recording. So if you want to see it, you should go there. We will be talking about these things in the future, but in general, it's like I want this community to be nice and inclusive and friendly to each other, and make awesome hardware while we are at it. Yeah, so thank you for all of these questions. Today is awesome. It's a very, very interesting discussion on many fronts. So yeah. Oh, Electronic Eel. Why small r? I'm not sure. Like, what is the convention on the other parts? 10K? Oh yeah, it is 4R7. Yeah, right. So my notation for just 4.7 ohm, I think, is the E notation from the European old notation. Yeah, R makes sense. Sorry, taking it back. You did the right thing here.
And then isn't the ISO
confused for a second?
L or ANSI maybe?
Say again.
I think the ANSI or ISO or something, they use L instead of R or E.
Oh God, really?
I think so. I could be wrong though.
Yeah, no, I know that for resistors there's like several letters that are being used, and yeah. Someone even mentioned, it's like, oh, you should use ohm, but the ohm symbol was not available for a while, but now look what is happening here. It's like, at least on the silk screen I have it here. 10 kilo ohm, but it is for documentation purposes. So on like the user end of the PCB silk screen, so I'm fine with doing that there. But yeah, the convention, I think the R convention is the most self-explanatory. Oh, the Japanese electronic Twitter? Yeah, yeah. I do follow some of that, even though I don't speak Japanese or can read Japanese. Thankfully, the automatic translation is not terrible on Twitter, so it is possible to decode some of this stuff. And they are posting a lot of really cool, weird electronic stuff on there. It's nice. Oh, you tried to guess them? Okay, let's see. I think you... Let's see. What's going on? Symbol, edit. Yeah, what do I have to check my other bill of materials. I don't remember. It's just only hitting me because I think I'm using E here, but I'm not sure. This all looks somewhat wrong for some reason, and I don't know why.
Okay, I was mistaken about the L thing, but it is, yeah, R is from the RKM code, which is from some bunch of DIN and ISO and IEC standards, and so R is, although it's capital R. So it's all confusing.
So maybe that's the problem here, that it should be capital R.
I think so.
407. Yeah, maybe. But we are using lower letters for all the other ones, where it's like 49K9.
Right. So the standard says that for K it's supposed to be lowercase, but for mega it's uppercase, for giga it's uppercase, for milli it's lowercase, for micro it's lowercase.
Okay.
So I'll post the link.
Yeah, post the link for the standard. Yeah, I guess we should pull it up to some standard. Kriba is asking about my keyboard. Yeah, it's like we have 15 minutes of this stream. Let's squander it completely. Anyways, Kriba, how do I like I love this keyboard. C-unit convention. Yes, Tipfeli, that's correct. Yeah, I think this is aligned with the Psi-unit convention. I think that would be right. Though kilo is strange. Yeah, and then you have like KB bytes and kilobytes. It's like I'm currently fully confused when people say KB bytes versus kilobytes, and I always think kilobyte is 1024 of 8-bit characters. Anyways, yeah, we are trying to standardize things, and then we confuse ourselves even more. Yeah, I don't know. There has to be some reasoning that the big K means something else. Anyways, so I have two of the Keyboard IO keyboards myself. Actually, one here and one at my main computer. I love those keyboards. They really helped get my progressing carpal tunnel under control. So that's good. I do like how they feel. They're a little bit taller maybe than they should be, but this is not really an issue, especially because you are resting your palms onto the keyboard. It did take me some getting used to, but my first switch was from a normal keyboard to Dvorak many years ago. And this is where I finally learned to basically touch type. This is the thing that a lot of people are telling me. It's like but I would have to learn to touch type. This is so hard. It's like it's much easier to switch to a completely different keyboard layout and learn to touch type than use your existing layout. So the bigger the jump, the easier it is actually to learn it. That's what I learned by doing these two things. So essentially, if I only went from a normal staggered keyboard to a matrix layout, which like there's like columns and no staggered keys, the difference in the position of the keys is small enough that I would really get annoyed. I saw that. So jumping from a normal keyboard to a keyboard I/O, which is very different in where the keys are, is an easier step because you put it in your brain in a separate bucket, like learning bucket. So I use Dvorak layout on my keyboard I/O, and I use a keyboard I/O keyboard. So for me, switching back to a normal keyboard is not a problem. I type as fast on a normal keyboard now than I type on a keyboard I/O, even though the position of the keys is very different. And the same thing, yeah.
I did the same thing
go ahead, Jordi.
For Colmac, and I never learned touch type before that. I had learned playing video games, so I had this weird claw grip and not actual home rows. And so I was like, if I'm going to learn how to touch type, I might as well learn a better layout. And just like you said, making a bigger change ends up being easier because it's a different bucket in your brain.
Yes, exactly. So that was you confirm my experience with Dvorak in my case. Essentially, also what I find interesting, it is learning new things that are like physical like this. It has it's massaging your brain matter, and it's very nice. It's like when people say it's like, oh, I'm doing crossword puzzles to keep myself sharp. It's like I think learning new keyboard layouts could be considered a similar thing. I like trying out new things. I did also back their new campaign with the Arteos keyboard. I'm really looking forward to that. So that's Jordi Parky Rodriguez, and he's here in voice a guest, and he worked on the bitsy. So, so the new version of that. So we are almost over here. I obviously I didn't get to any layouting here really, but that's fine. We don't have to always be fully productive, but I think we had very good chats and some good updates. Especially a lot of stuff happened in in between the streams. It is nice to see more parallel threads happening. That's what is also lovely about these things that we are working on. It's like having you, Jordi, work on the bitsy while Electric Eel is working on the Glasgow, and I'm working on documenting the reflow oven conversion. It's like we are getting basically more things done as a community, which is really cool. I have not expected that this will evolve like that. I'm pretty much used to the fact that it's like, oh, I have to do everything myself. And this is becoming pretty amazing. Yeah. Again, for the 50th time, thank you, Jordi.
Not a problem. It's mutually beneficial.
Yeah. Anyways, cool. As I see, it's anyways 10 minutes here. So I think so what is the question? How nicely does KiCad play with Git versioning? That's a very good question. There is this link that I keep showing here on stream. Where is it? Do I still have it open somewhere? There. This is it. So this is, I will post this. So there is a lengthy, I still have to do this. This is something on my to-do list. There is a documentation of how to massage your GitHub or Git repository. And there are ways of doing diff even, and the problem is there is some KiCad stuff that is still generating churn in the diffs, which you can decrease by adding special pre-commit hooks and filters. I wish KiCad did it by default, And I think this will happen eventually with the new file format being in the place and whatnot, blah, blah, blah. But yeah, there are also tools to do visual diff of parts. But yeah, I don't have it set up. It is good enough for one person really working, but if you have to coordinate with several people. So that people don't touch each other's, don't stomp onto each other regarding PCB design. Unfortunately, I wish this was even better than that. But yeah, so this is the Keyboard.io website. It's on Kickstarter, but there's also their
actual website doesn't seem to list the Model 1 anymore, so that's why I just put the Kickstarter link.
Oh, yeah, it was listed as sold out the last time I checked, because they are working on a new, join the wait list, the amazing keyboard on your desk. So there is that. So on the front page, you have the wait list.
Their new one, the Atrius, looks fantastic.
So they are working on a new version of the Model 1. That's why this one is at the moment sold out. But I think some people were selling their keyboard AS, because this is not a keyboard for everyone. They were selling them on eBay after the campaign. Some people were like, this is not right for me, which I can understand. This is very different layout, so you have to, with both feet, commit to it and actually spend some time learning. So, but I would think on eBay you should be able to find it. That's a very good question. So first of all, the Artios is the current project. So let me finish that. And this is the new keyboard they are working on, and it is using the Kilia, or different pronunciation people use for the Kilia switches. So you can buy them. They are actually quite affordable. This is what Jesse is the founder of Keyboard.io with his wife. He worked pretty hard to get those key switches at a more reasonable price available. So if you are buying mechanical switches, this is pretty good option to buy them actually from Keyboard.io, because they are very affordable here. So you get 25 switches for $7. And these are really good switches. I got some of them to try out in the RTOs because I was not sure which ones I like the best. So that will be interesting. So yeah, I am getting slowly into this like mechanical keyboard craze, and so which key does have the right thonk to work for you? Anyways.
Yeah, you just gotta get to the point of getting a huge switch tester and then settling on a keyboard that sounds like this.
Well, it's not. Some people go for the sound. Some people go for the feel. Some people. It's such a subjective thing, which is such a wonderful thing to be subjective about, because it doesn't hurt anyone.
Yes.
And, it's
your wallet.
It's like, yeah, we can obsess about our keyboards without like putting that energy in some weird places. It's great. It's wonderful. I love it. So yeah. Yeah. So do they study coding in electronics and electrical in uni? What is the question here? I'm not exactly sure. Nasser Kal. Do they study coding in electronics and electrical in uni? Oh, if they teach that in uni. That's the question? Oh, right. Yes. So Zipfeli, that's a fair point. It's like the loud keyboards. I think this is the only, yeah. But then we can get into this whole discussion. It's like, is actually a central workspace and not working from home better or worse? So it's like this can go down a very interesting rabbit hole there. But yeah, I hope that more people will be able to work from home more, even though being in person to discuss things is very important. So it should be probably a mixed setup. Yeah, it's an interesting conversation to have in that specific spot. It's like about workplace pleasantness, and it's like, yeah, loud mechanical keyboards in the workplace. And this is probably rude, fair, but you can have a loud mechanical keyboard in your home at your home computer. So maybe that's the compromise. You just use your loud mechanical keyboard at home, and the quiet one at work. Yeah. Yeah. Or you mean Tifeli, or is it the other question? It's like, are people fighting? Is there like around the cooler, there's like a ring to fight out who likes which keyboard? Yeah, I hope not. Yeah, you don't like programming, although you were studying computer science. Well, um, that's I'm not sure how to address this, to be honest, because computer science does. Arturo182, thank you for the follow. Welcome to the stream. So coding is not the essence of computer science. It's problem solving in general. Yeah, it does show up. I saw you. Yeah, the sound environment. Yeah, okay, that's yeah, less of a problem. But yeah, yeah, the audio stuff is an issue. I heard that a lot, especially it's like the non office, like open plan offices where it's very loud. I found it very difficult to work in an open plan office. Especially because people could just come up and disturb your flow on any minute. That was the biggest problem, I think. So I think for engineering in general, you need to get in the flow. You need to be able to get into this spot where it's like you are being productive, and the ramp up and ramp down is very long, for me at least. And I heard that from pretty much everyone I know. So you need to be able to get into this, and if you can be disturbed by others, that's a problem. So that's one. Two, the sound environment. It's like if you have a loud sound environment, you have to have like noise canceling headphones that work not great for interrupted sounds. And then people are like, well, why don't you hear me when I'm calling you? Because I'm having my headphones because I need to have it quiet. Anyways, yeah, it's all very complicated. I'm not sure what the right solution is. It's like, but loud mechanical keyboards at the workplace, that's probably not the right thing to do. It's like, so get one that is very tactile and quiet, I guess. I don't know. Depends on the situation. So let's get back to the programming standpoint. It's like there's a lot. So computer science is not teaching you how to program. It is there to teach you how to solve problems, and how to approach them and how to research them. That's what I was taught at university, and this is what I took away from my computer science degree. It's not there to teach you to program per se. Also, programming in general, it varies a lot between different programming languages, and how it feels to program, how immediate it is. The biggest problem with programming is you need to have an intrinsic motivation to actually do it, so that you get good enough at this so that it is fun. And it's really hard if it is not a direction you choose without having this motivation from the inside. It's like, this is fun for me to do. So yeah, I'm sorry programming is not fun for you, but maybe try finding a project that would require some programming to find the pleasure of accomplishing something with the programming as a tool. That might be a way of helping that out. Because if you do computer science, at the end, in some shape or form, you will have to program, and if you don't, and you just go into the management position where you tell other people what to do and what to implement, if you don't have any experience programming yourself, you will not be a good manager. So there is an element of understanding programming in the paradigms and how it feels to build stuff to a certain degree to be able to do these things. But computer science is not there to teach you programming, in my opinion. It's there to teach you how to solve problems. So this is my take on this. It's like, Jordi, do you have like a view on this?
Yes, definitely. I have had many friends who have had not had a background in computer science or in writing software, and who have, for various reasons, wanted to learn. And what I've found over the years is that the ones who end up being successful and enjoying it and keeping with it are the ones who see it as a tool for a purpose and have projects in mind that they would like to solve. And then, because you have a goal, you can easily be like, oh, well, I need to go down this rabbit hole to learn this tool so that I can use that to solve my problem. Whereas the ones who just kind of, I've had friends who are like, oh, I would like to learn how to program. And I ask them why, and they're like, oh, because, people are saying that people should learn how to program, and there's no real goal, there's no real problem that they're trying to solve. And then it's really hard to stay motivated if you're just doing lesson after lesson of these arbitrary, write a program that prints out hello world, write a program that does this thing. And those things are necessary at the beginning, but it's really nice to have an actual purpose with it. And that's the same with anything, with hardware. If you want to learn how to use KiCad, it's better if you have I would like to make this thing, and I would like to learn how to make this thing that I have in my mind.
Yeah. That's a very good point. There is a very fine also relationship between how much of formal learning you do before you do programming, and how so for example, I knew only Python as much as I needed to modify certain things in scripts that I happened to come across. And then I was like, well, I am confused about a bunch of the concepts here. I think it is time for me to actually formally learn the basics of Python. And I did invest a week and a half or something to every day go through those exercises one by one and build up the basis for that language for me. Of course, I know other programming languages, so I have some other basis, so I understand the concepts, but it's like the mechanics and the syntactic sugar and how the language behaves. You have to at some point learn the where is the square screwdriver, where is the slot screwdriver, where is the drill, where do I find all these things? But this is it feels like a tedious part, especially there's another comparison you can make. It's like, why learn math if you are not using it for something? But then you can say, it's like, yeah, but in engineering, you then use math for this and this and this to build things. And you're like, oh, wow, that's awesome. I can use this for building these things. And this is many cases where people get excited about actually learning math, right? If you actually have a purpose for it.
Yeah.
Yeah, okay, so, all right, so we had this conversation, that was nice. I think this is where we will wrap up the stream. So again, thank you, Jordi, for joining the stream today.
Yep.
I really appreciate it.
I appreciate you having me on here.
Yeah, and I hope we can repeat that again in the future, as well as with you, as well as with others, hopefully. This was a lot of fun, and having you explain what you built, that was awesome. Otherwise, thank you everyone for being here and being part of this, being wonderful people of the community and helping out. Thank you for everyone who is supporting all this by buying stuff from 1BitSquared if you need it, or by supporting through subscriptions on Twitch. As well as those that are the wonderful Patreons that are supporting these streams and pitching into the tip jar in a way. Really appreciate it. It really helps. Making all this is not easy. Unfortunately, we are in the world we are in, and things have to be paid for. So thank you so much. And I would like to give a shout out to the people that are in the shout out tier here on Patreon. So thank you very much to Aki Van Ness, Jamin, Brennan Ashton, Ben Venick, Drew Fustini, Edward Borden, Go Jimmy Pie, Jeff Wang, Jordi Parky Rodriguez, Kelly, Matis Schmidle, Matis Pritchett, Miha Benovets, Sean C., Tom Keddy, and there was one person I think that got added this week, but I didn't update the list, so I'm very sorry, and thank you very much for supporting. And I will definitely give you a shout out next stream. And yeah, as always, if you have been, thank you for watching. Bye.